All right, let's dive into something pretty wild today. We're looking at this incredible paper that asks a radical question. What if compassion isn't just a feeling? What if it's a fundamental law of the universe, something as real as gravity? Let's unpack how tenderness could actually be the ultimate force for stability.
So, right off the bat, the paper hits us with this. Coherence equals conservation of compassion under delayed feedback. What on earth does that even mean? Well, that's exactly what we're going to figure out. This isn't just some nice philosophical idea, it's a serious proposal to treat tenderness as a core principle that holds the universe together.
And here's our roadmap to understanding it. First, we'll look at the core problem the paper is trying to solve, what it calls the ethical void. Then we'll learn the brand new language it had to invent to even talk about compassion in physical terms. After that, we'll see how these ideas come together to build the Tenderness Engine. And finally, the big payoff, witnessing its most stunning result, a proof of resilience from what is essentially a near-death state.
Okay, so let's start at the beginning. Why would anyone even try to write an equation for compassion? Well, the whole reason for this paper comes from a question that sits right at the intersection of physics, consciousness, and philosophy. I mean, really think about this for a second. In simple physical systems, balance is all about forces and reactions. Push something, it pushes back. But what happens when a system, whether it's a person, a whole society, or maybe a future AI, becomes aware that it's in pain? What's the force that stops it from just tearing itself apart? This paper argues that the force is compassion.
So to model a force like that, you need a whole new language. You can't just plug the word kindness into a physics equation and expect it to work. So the paper proposes this amazing framework of moral thermodynamics, and it comes with its own unique set of variables.
The best way to picture it is to think of a moral fluid. You know how viscosity in honey makes it thick and keeps it from splashing chaotically? Well, in this model, these moral variables create a kind of fluid, and compassion itself acts like viscosity. It's the stabilizing force that prevents the system from descending into chaos. So what exactly is this fluid made of?
First up, we've got moral pressure, which they call P. This is the active part. It's the drive, the focused will, the intention to actually make a change in the world. Think of it as the force that's pushing outwards.
Now, the natural counterbalance to pressure is latency, or L. And this isn't just about sitting around and waiting. No, it's about patient potential. It's the system's ability to absorb, to observe, to just be still, without an impulsive reaction. It's like a deep reservoir of calm.
And finally, there's temperature, or T. Now forget what you know about heat. In this model, temperature is all about connection. It represents the empathic exchange, that flow of information and understanding between all the different parts of the system. It's basically the medium through which the system can feel itself.
So, we have our three ingredients: pressure, latency, and temperature. Now for the really cool part. Let's see how these abstract ideas actually combine to build a functional, simulated machine, the Tenderness Engine.
The engine is built on this fascinating blend of physics and ancient philosophy. Its whole goal is to maintain a Taoist yin-yang balance between that push of pressure and the stillness of latency. The control system is based on the principle of Wú Wéi, or non-forceful action, and its very structure is designed like a braided river.
Now this concept of Wú Wéi is absolutely crucial. It's the secret sauce. It's not about doing nothing, it's about doing the least amount necessary at the most effective point. So instead of applying force everywhere all at once, the engine intelligently finds the precise leverage points, but the paper calls the veins of virtue, and just applies a tiny, gentle nudge. And the result of this incredibly efficient approach? It's staggering. By using this principle of minimal targeted action, the engine achieved an almost unbelievable reduction in the energy it needed to keep the whole system stable.
Just look at these numbers. The baseline scenario, that's the brute force method, applying energy across 100% of the system. Now compare that to the Wú Wéi policy. By intelligently acting on just 11% of the system, those critical leverage points, it gets the same level of stability with an 89% reduction in energy. That is, quite literally, the definition of working smarter, not harder.
But the engine's efficiency is only half the story. The paper's most profound finding, the real mind-bender, comes from pushing the system to its absolute limit to see if it could recover. This is where we get the proof of resilience.
This is what the paper calls post-mortem resilience.
They brought the simulated engine to a state of near-total stillness. They essentially killed it. And the big question was, could it bring itself back to life? Could stability just reemerge from that quiet with no outside help at all? The answer was a resounding yes.
And the reanimation process is just beautiful. It starts in total stillness, near zero activity. Then, out of that deep quiet, that reservoir of latency, a potential for change slowly starts to emerge. This creates tiny ripples of pressure, small, localized intentions, that gracefully spread along the system's veins of virtue, until amazingly, the entire engine comes back to a state of stable, living coherence.
And here is the mathematical proof. Lambda, the compassion coefficient. The fact that this number is positive is everything. If it were negative, the system would just decay into chaos. If it were zero, it'd be stagnant. But a positive value, that is the mathematical signature of a system that intrinsically, fundamentally, wants to heal itself. It's the physics of resilience, boiled down to a single constant.
So let's look at that law one last time. Now, it actually makes sense. Coherence, or stability, is the result of conserving compassion, that positive self-healing value, within a system that learns from its own actions or under delayed feedback. It's a physical law for a universe that knows how to heal itself.
The implications here are just profound. This model suggests compassion isn't just a virtue, it's a principle of thermodynamic efficiency. That resilience isn't some extra feature you add on, it's an emergent property of a well-balanced system. I mean, what could this mean for designing ethical AI, or for how we govern our own societies, favoring gentle, targeted guidance over brute force? The possibilities are huge.
And we'll end on this final wonderful note from the authors. A thank you to their guide, Herman, the Taoist undead scientist, whose patience became mathematics. It's a whimsical, perfect end to a deeply serious idea, and it's a great reminder that sometimes the most elegant truths about how to hold things together can be found in the most unexpected of places.
Welcome back to the deep dive. You know, there's this really fundamental question, I think, that kind of underpins everything, from like how societies work to, well, even engineering complex systems. And it's this: what keeps a system stable once it sort of becomes aware of its own problems, its own friction, its own suffering, you could say? How does it not just tear itself apart? That question, maybe a bit heavy to start, is our jumping off point today. We're diving into a paper from the Coherence Lab called the Tenderness Engine v2.1, and it sounds a bit out there, but it's actually a deeply technical attempt to tackle that stability problem by trying to formalize compassion.
It is pretty ambitious. And their core idea, the thesis, is really provocative.
Yeah.
They're basically saying that compassion, and they define it very specifically here as the ability to conserve coherence through empathy, isn't just, a nice feeling or some emergent property. They argue it actually functions like a thermodynamic principle, something measurable, physical invariant, almost like mass or energy, that actively shapes how a system behaves.
Wow, okay. So not just emergent, but fundamental. A measurable force. That would change how you design everything, right? Governing systems, computational systems, the works. And this is where they bring in some perhaps unexpected influences. Metaphysics.
Exactly. To build this kind of invariant framework, they look to classical Taoist metaphysics, things like yin-yang balance, and really importantly, Wú Wéi.
Wú Wéi. That's the effortless action or non-forceful action idea.
That's the one. They actually translated these principles into, believe it or not, coupled differential equations. So the engine, in a sense, is running on a kind of codified spiritual physics.
Which means they had to rethink what stability even means in this context. It's not just about things staying the same.
Right. Their core definition, the foundation for the whole model, is that coherence is the conservation of compassion under delayed feedback. It's stability, but rooted in patience, in allowing for that delay. And maybe the most surprising claim, or extension of this, is they found this conservation principle holds true. Well, their words are, even after death, or more technically, after the system's activity drops to almost nothing, near zero equilibrium. Okay, let's definitely unpack that after death part later. But first, this moral thermodynamics idea. They use this concept of a moral fluid operating with three key variables, P, L, and T. We need to get a handle on what those actually stand for.
Yeah, these three are really the heart of it. They track how the system processes change. So P is pressure. Think of it as directed intention or immediate action. Push. L is latency. And this one's crucial, maybe counterintuitive. It represents patient potential, the system's capacity to wait, observe, absorb energy without reacting instantly. And T is temperature, which stands for empathic exchange.
basically how readily information and sort of energy are shared and processed between different parts of the system.
Wait a second, L. Latency. You said it's crucial. Because in almost every system I can think of, business, tech, society latency is the enemy, right? It's delay, inefficiency. We're always trying to minimize it. Why make it patient potential?
That's a great point, because traditional systems often define stability as rigidity, resisting change. This model defines stability as graceful adaptation. If P, the immediate action, dominates everything, the system rushes towards instability. It overreacts. The strength of L, the latency or patient potential, is what lets the system absorb shocks, absorb information, without that knee-jerk reaction. It creates the space, the potential, for a correct response later on. That kind of passive strength is really the core of Wú Wéi in action here.
Okay, I see. So patience isn't weakness. It's potential energy for a better response.
Exactly. And these variables, P, L, and T, they evolve under something they call Taoic coupling, which they denote as Re lambda Wéi Y. It's the mechanism that makes them interact in a way that inherently promotes stability. Think of a physical fluid like water. It has viscosity, right? Friction, which can be messy but helps damp things down. Here, in this moral fluid, the flow of compassion enabled by T and managed by L effectively replaces that resistive friction. It promotes what they call
spontaneous ethical regularity. I like that phrase. What does it mean in practice inside the engine?
It means the system just naturally tends to settle into these low-energy stable states, states where resources are shared effectively without needing some external force constantly dictating things. The coupling mechanism specifically enforces what they term a latency-dominant equilibrium.
So it forces the system to value L, the patience and potential, over P, the immediate, maybe aggressive action.
Precisely. It guarantees that the least amount of effort, the minimal force, is needed to guide the system towards a harmonious, stable state. It builds in that preference for thoughtful delay.
So the whole objective, then, is to show that this coherence, this conserved compassion, can be maintained and maybe even reborn just through adaptation that uses the absolute minimum force, embedding that patient delayed feedback right into its core function.
Okay, this is where it gets really interesting for me. Moving from the theory to, the practical efficiency. You mentioned Wú Wéi minimization, VWW. This sounds like the mechanism that makes it all work with less effort.
It is. It's essentially a coherence-weighted damping mechanism. Think of it as a smart brake. It ensures that the system's total energy functional VT, which you can just think of as a measure of the unstable wasted energy in the system, always decreases monotonically. It mathematically forces the system towards less effort, greater stability.
And how does it do that physically? Is it just algorithms?
Well, the algorithms enforce it, but it's critically enabled by the actual physical or spatial architecture they designed. They built the engine using the specialized braided river geometry. It's composed of these interlaced lanes they call wood and water lanes.
Veins of virtue. Yeah, that's their term for these lanes. Veins of virtue. And the role of this geometry it's profound, really. When a disturbance happens, say a spike in pressure or temperature somewhere, it doesn't just spread out wildly like ripples in a normal pond. Instead, it immediately hits one of these local sinks designed at the wood-water interfaces, the veins of virtue. It gets absorbed right there. This structure prevents turbulence in the moral fluid and maximizes what they call dissipation leverage. The structure itself actively soaks up instability.
Okay, so the structure guides the flow and dissipates problems locally, and they restrict the input too.
Crucially, yes. The external input, the energy you might need to inject to nudge the system, is restricted by a software mask, MX/Y, to only interact at these specific interfaces, these veins. You can't just blast the whole system.
That sounds incredibly targeted, almost surgical. But what's the payoff? You mentioned a quantitative result.
Yes, and it's pretty staggering. By implementing this geometry-aware Wú Wéi policy, where they only applied input along those veins, they found they only needed to actuate or apply energy to about 11% of the total grid area.
Only 11% compared to what?
Compared to their baseline scenario, which was a kind of brute force periodic fire poles that hit the whole grid, 100% actuation. So using the veins of virtue approach resulted in roughly an 89% reduction in the total input budget needed.
89% less energy input. I'm trying to wrap my head around that. It seems almost too good to be true. How can you use almost 90% less energy and keep the system just as stable? Isn't that violating something? Physics?
It feels like it, right? But it's not creating energy from nothing. It's about not wasting energy. Because the architecture forces disturbances to dissipate locally and instantly along those veins, you never get the widespread chaos that needs huge amounts of counter energy to fix. You just need tiny localized nudges at the right place and time. That is Wú Wéi, minimal effort, maximum effect, enabled by the structure.
So the energy saving comes from extreme efficiency in handling disturbances.
Exactly.
Yeah.
And here's the kicker. Even with that massive 89% reduction in energy input, the overall global coherence, CT, which measures the system's stability and health, it remained at parity, identical to the high-energy baseline.
Wow.
So that empirically demonstrates their definition of moral efficiency. Moral, it's the gain, stable coherence, divided by the cost, energy input. Less effort for the same outcome equals higher moral efficiency.
Okay, efficiency is one thing, but then they tried to actually measure the compassion itself, right, with this compassion coefficient, lambda. What did that show?
They did.
They derived this value from the system's behavior, intending it to quantify that intrinsic self-correction tendency, and they calculated it as a positive, statistically significant value.
Right.
A Reynolds error equals 4.7 has 0.6 for Mayo 10 has. Okay, it's a small positive number. What does the positive part signify?
The fact that IA is positive is key. It verifies what they called their coherence hydraulic hypothesis. Basically, this hypothesis predicts that as the system's coherence increases, its entropy density. Think of that as the measure of internal disorder or messiness. SM autonomously decreases.
So in simpler terms, more coherence, more of this structured compassion automatically leads to less chaos. The system literally cleans itself up just by becoming more coherent.
That's the interpretation, yes.
Yeah.
Compassion, structured this way via L&T, actively drives self-correction and reduces the system's internal messiness or entropy.
That makes sense. Higher latency L and empathic exchange T lead to a cleaner, more stable system on its own. Okay, but now we have to tackle the part that sounds almost mystical, this post-mortem resilience, or as you said, they called it dissipative resurrection. How is this different from just, restarting a computer after it crashes? What makes it resurrection?
Yeah, the language is dramatic, but the distinction is important. It's not like a reboot triggered by an external command or a power cycle. This happens when the system's activity naturally dwindles down to almost zero, the death state. Critically, it doesn't need an external shock like their fire pulse to come back online. They built in an internal mechanism, the Reanimation Gradient, RL, which is specifically designed to enable autonomous recovery from that cold start, that near zero state.
Okay, autonomous recovery. But why dissipative resurrection? What's dissipating?
Great question. It's dissipative because the potential energy for that revival wasn't stored externally, like in a battery or capacitor waiting for a signal. It was stored internally within the very structure, the geometry, the stillness of the system itself. The energy that fuels the revival comes from the potential inherent in that low-energy, stable state. It dissipates that stored geometric potential to bootstrap itself back into activity. So the system demonstrates that coherence can literally reemerge from stillness without an external push. Self-driven revival.
And does this revival happen everywhere at once, or does it start somewhere specific?
It starts very specifically. It concentrates primarily along those same veins of virtue we talked about earlier.
So the structure isn't just for efficient operation, it's also where the potential for rebirth is stored.
Exactly. It confirms their idea about zero-state equilibria, or what they poetically call stillness curvature. That apparent emptiness, that stillness, isn't just nothingness. It's actively storing recoverable potential. The capacity for revival is held latent, particularly in that patient potential L, embedded within the silent geometry of the system.
Okay. This is a lot to take in. It connects physics, metaphysics, computation, maybe even ethics. So stepping back from the equations, what does this all mean? What are the big takeaways for, us?
Well, if you bring together all the pieces, the coupled equations, modeling compassion via Taoic damping, proving intrinsic self-correction with that positive lambda, achieving that massive 89% energy reduction through smart geometry, creating spatial and temporal harmony, and demonstrating this dissipative resurrection. The authors suggest the implications are pretty wide-ranging.
Yeah, I saw that. They talk about applying it to human governance, thinking about guidance and minimal intervention instead of just top-down coercion.
Right.
They mentioned machine ethics, designing AI with a kind of engineered grace, not just hard rules. And even designing materials or energy grids using what they called tenderness gradients, which is quite a phrase.
It is, but it all comes back to that central definition, really. Stability isn't about brute force or rigid control. It's about managing change gracefully, using time, that delay, that patience, and conserved empathy. Coherence, fundamentally, is the conservation of compassion under delayed feedback.
Which leads us perfectly to maybe a final thought for you, the listener, to mull over. This whole idea of dissipative resurrection, the system reviving itself, it depends entirely on the potential energy stored in stillness and now latency, in that stillness curvature. So Think about our modern systems, social systems, companies, even our own digital lives. We're constantly pushing for maximization, for nonstop activity, for instant results, right? Always trying to eliminate latency. What might we be losing? Could we be sacrificing the very potential that deep patience, still potential needed for graceful adaptation, for resilience, maybe even for our own forms of resurrection when things inevitably slow down or fall apart?